Algebra 1, Day 21. Today we're going to be talking about generating equations for parallel lines. So before we even get into our notes, there's a couple of things that we need to go over first. Okay, so number one, the word parallel means never touching, no intersections. Now, parallel lines will always have the same exact slope. Okay, so for example, here I have my coordinate grid. If I have one line that looks like this, a parallel line would look exactly the same way. Notice how it's facing the same direction, and they will never touch. So even if these lines go on forever and ever and ever and ever, they will never touch. So even if it's here, 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 it's still parallel because they will never touch because they have the same slope, okay? Now, there's also called perpendicular. And oh, forgot to mention, the symbol for parallel looks like that. Perpendicular means they intersect at 90-degree angle, sometimes called a right angle. And in carpentry, they call it square. Okay? That means that you should be able to see, and I'll go ahead and draw out another coordinate grid. So here's my X and Y axis. If I have an original line, let's say heading like this, my line that is perpendicular to it will look like that. And they will intersect, touch at 90 degrees. And usually people write in a box that looks like this to tell us 90 degrees. The symbol for perpendicular looks like this. All right. So these have what is called opposite reciprocal slopes. Okay, opposite reciprocal. So let me go ahead and add one more page to this. And I'm going to continue this, and I'm going to write out a chart of different slope values. So I want you to pay close attention. So over here is going to be my original slope. M2, M3 are going to be new slopes. Okay? Now, I want you to tell me, what do you notice about the numbers that are written in green in comparison to those that are blue? They are exactly the same. So these guys are parallel lines because they have the same slope. Okay. Now, let me go ahead and write out some more values. So I'll write these guys in pink. So what pattern do you notice in between the pink numbers and the blue numbers? These guys over here are what is called opposite reciprocal. That means drop a negative in front of it and flip it upside down. Now, one of them is a little weird because remember, we do have something called an undefined slope. That's the one that goes straight up and down. The one that is perpendicular to a slope of 0, side to side, goes straight up and down, which is undefined. So, this is the way that you should think about it. Anytime somebody tells you my line is parallel, you automatically know it's the same exact slope. Don't let anybody confuse you. Parallel, same exact slope every single time. All right? So, let's go ahead and take a look at today's notes. Okay. I'll go ahead and start filling in. So parallel lines are lines that have the same slope. As a result, they will never intersect or touch, ever. You can also say cross and other various words. So let's take a look at an example. What is the slope of a line that's parallel to 2x minus 1? First thing I'm going to do is I'm going to identify what is my current slope. I like to call that M1. So it's 2. If M2 is parallel, it's also going to have a slope of 2. That means that line 1 is parallel to line 2. This is something you may come across in the future. Okay. So let's look at example number 2. Generate an equation that represents a line that passes through this point and is parallel to the graph below. All right. So I can tell you lots of different ways to do this. We can graph the point and just trace out the slope. We can grab the slope, grab the point, plug it into point slope. We can grab the point, grab the slope, plug it into slope intercept and solve for b, and then make our equation. Lots of different ways we can do this, okay? So the first thing that I want to do is find this point, this guy up here. So 8, comma, negative 6. Okay, there's my point. So now what I'm going to do is I'm going to look at my original line, and I see how it has 6 boxes, 2 up and down, 3 to the right. So I'm going to follow that same pattern. I'm going to go 2 up, I'm going to go in the opposite direction. 2 up, 4 to the left. 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 All right, so it looks like my line is pretty decently parallel, so I'll go ahead and draw my line, put my arrows just in case anybody is suspicious that these guys don't stop. So I have what the graph looks like. So I'm going to figure out what the slope was. So again, because this is parallel, M1, which is going to be my black line, is down to right 4. So that means my new slope is the same exact thing. All right. So now I'm going to go ahead and I'm going to use one of my equations to solve for it. Remembering I can use y equals mx plus b, or I can also use point slope form. I can also simply look at my graph and figure out what it is. This should be y equals negative 1/2 x minus 2 based on this new y-intercept. But I'm going to go ahead and go through the process anyway. Y equals mx plus b, all right? So now I'm going to go ahead and put in my slope. Oh, excuse me. Hold on, my slope. And I do not know my b value yet. So I'm just going to go ahead and plug in this y as well as this x. And let's see what happens. Negative 6 equals negative 1/2 times 8 plus 4. Negative 6 equals negative 4 plus b. b equals negative 2. Noticing that matches up exactly with this guy. My equation should look exactly like this. So let's go ahead and talk about the steps. So first, of course, I would calculate my slope, substitute my slope, also my letter m, and my ordered pair, x comma y, into y equals mx plus b. And remember, we can also use point slope form. We multiply, isolate b using the inverse operation, and this value that I get is my y-intercept. Rewrite my new equation to include my slope, m, and my y-intercept, b. All right, let's take a look at our next one. Generate an equation that describes the line that passes through the point 4, 7, and is parallel to the line that's written in standard form. So they are really trying to trick me here. So remembering standard to slope-intercept, because slope-intercept is the only thing we know how to graph, and it's the only one with an m in it. So to convert from standard form to slope-intercept, to determine the slope of the line, we always use exciting move, great divide, every time. So first thing I'm going to do is I'm going to go ahead, I'm going to copy over. Oh, okay, let's see, let's try it one more time. Copy. Okay, well, it's not going to work for me today. So I'll go ahead and just write it out. 5x minus 4y equals negative 8. I'm trying to get my y by itself, so I need to get rid of everything else. I'm going to do exciting move, and whenever I rewrite it, I'm going to put my x in the front just simply to make it better and closer to y equals mx plus b. Now I'm going to do my great divide. Everything I see, I'm going to divide by negative 4. 2 negatives make a positive. 2 negatives make a positive. And I have an equation. So I'm halfway there. Boy, this is a long problem. Okay, so step 2. My original slope is equal to 5/4. Right? And I know that line 1 is parallel to line 2. So in order for me to find the slope associated with 2, it's exactly the same. All right. So now what I'm going to do is I'm going to plug that in. I'm going to say y equals mx plus b. So I'm going to look back at my problem, and I'm going to say, all right, first thing I see is that y is a 7, and that x is a 4, and of course, whoops, wrong one. My slope is this 5/4. So let's plug them in. 7, 5/4, 4 plus b. I need to solve for b. So these 4's cancel out. And I end up with b equals 2. So almost there. Man, this is long. All right. So I'm going to take my 5/4, my y-intercept. I'm going to plug them back into an equation. This is my final answer. All right? So now that we've talked about that, remember parallel lines have parallel slopes, okay? So what you need to do is go ahead and take a look at the example questions, and I will see you guys next time.